In this video, we're going to talk about simplifying exponential expressions. All right, so I say you should be comfortable with all this, but we're actually going to review it really quick. All right, so we've learned a lot of rules about exponents, so let's quickly look over them. All right, first, we started with when they're whole numbers, or like when exponents are being combined together. If you multiply, you add the exponents. If you divide, you subtract the exponents. If you have a double exponent, that's when you multiply. All right, so that's how we combine two things into one. And then our other rules have to do with the specific type of number. If we have a negative number as an exponent, we just move it to the other side of the division bar. So in this case, we put it over 1 and then move it to the bottom. Here it's already on the bottom, so we move it to the top. And the last thing we learned was about fractional exponents. These are the two most common ones, but it works for any fraction. Is that the number on the bottom just means it's that type of root for that number. All right, so now we have all of these different rules. How can we combine them? So this problem right here is like one of the main reasons that having exponent rules to represent roots is a good thing. If we were doing this just with our roots, I'd have no idea how to combine these two things. But using what we just saw in our last slides, the square root of x is x to the 1/2. The cube root of x is x to the 1/3. And now I know I can combine these two by adding them, using our first set of exponent rules. I'm going to kind of go to the side and do this, so don't mess up the rest of the problem. I need to get a common denominator, so this one I'm going to multiply by 3 over 3, and this one by 2 over 2. And I get 5 over 6. All right, so these two, when I combine these fractions, that's the same as x to the 5 over 6. And we're going to write it with no negative or fractional exponents. So this is technically fully simplified. We combine them, but we're going to rewrite it without these exponents. So two different ways you could do it. You could do the 6th root of x to the 5th, or you could do the 6th root of x to the 5th. I prefer this first one because it's less parentheses. So I would normally write it like this. All right, the whole number part is here, and the fractional part is there. All right, so that would be my way of fully simplifying. But you can see this is, you'd probably never be able to guess that these two things combine to this. But by now, having those fractional exponents allows us to use our normal exponent rules to combine these things and then get down to our final answer. This case, again, we just want to try to combine all these things as possible. You're really not going to be able to combine things when there's roots. So the first thing I would do is change this back to a fraction exponent. And then I would use my negative exponent rule to know that this wants to come up here. And now there's two exponents that I can add together. Again, I have a fraction, so I have to go to the side and get a common denominator. Remember, I can make any number over 1. This one already has a 4. This one just needs a 4 over 4. And I get 9 over 4. So this is the same thing as, oops, 8 to the 9 over 4. And again, for me, when I'm writing these most of the time, I'm going to do the whole number part and then the root on the outside. So it's going to be a to the 9th and the 4th root. All right, so the 4th root of a to the 9th. Also, you could write it as the 4th root of a to the 9th. Again, the reason I prefer this first one is just because I don't have to write extra parentheses, but both of these are acceptable answers. I'm going to do one more example. All right, the cube root of b to the 4th over the square root of 5, b to the negative 2. So again, whenever I see roots with my variables, I'm going to rewrite that as fractional exponents. This is 4 to the 1/3. All right, this kind of square root, I'm not sure why that's there. It's kind of just separate. That's just kind of going to stay there. That b can move up to the top. And square root of 5 is just going to stay down here. And now I know I can add these together now that they're on the same part of the fraction. 2. I get 10 over 3. And then b to the 10 over 3 is b to the 10th, and it's cube root. The only thing technically you would have to do for this one, I think there was a typo here, and that's why it ended up looking kind of weird. The only thing technically you'd have to do to make it a final answer is you don't like having square roots on the bottom, numerical square roots like that on the bottom of a fraction. So we would just fix that like that. All right, not super important for this lesson. I think that was a typo. But the part of changing this to a fractional exponent and combining them is important. All right, so here's one for you to try on your own. This -3 here should be in the exponent. It should be a little -3, not x to the -3. But go ahead and try this one on your own. I'll show you the answer in 3, 2, 1. And as always, there's a bunch of different ways you could go about this one. But the final answer I got is x to the 14th. So I moved this up, combined them into a single one, and then double multiplied. You could also distribute this 4 first, then combine. You could move this up and then distribute this 4 and then combine. There's a lot of different ways you can do it, but no matter what, you should get down to x to the 14th as your final answer. Quick summary. If you want to combine exponential expressions, rewrite all the roots as fractional exponents. It's the only way you're going to be able to use your exponent rules to combine stuff. Don't forget to get common denominators when you're combining fractions. You have to be able to add your fractions correctly to combine those roots. And then rewrite your final answer so all your fractional exponents are roots again. For some reason, if you're going to end up plugging in numbers, it's a lot more convenient to have like the 9th root of a rather than a to the 1/9, right? This is more useful when we're doing numbers. All right, so we want to rewrite our final answer without those fractional exponents again.